Now, in a previous video, I said that I'd show you some applications of the remainder and factor theorem, and that's what we're going to have in this one. Two examples of how the remainder and factor theorem get used. So here's our first example. We've got a function. I'm going to call it, I'm going to need to write a pen first of all. I'm going to call it f of x. I'm going to say f of x is x cubed plus 2x squared plus ax plus b. Now, what have they told me? They've told me if I take that function and divide it by x minus 1, the remainder is going to be 11. So if I'm dividing by x minus 1, if I go and substitute f of positive 1, the thing that will make that bracket over there 0, I'm going to get my remainder, and that remainder is going to be 11. If I go and find f of minus 2, the value that will make this bracket over here 0, that's going to give me a remainder of minus 1. So all I have to do now is go and substitute in those values for x. So if x is 1, I'm going to be left with 1 plus 2 plus a plus b. And if x is minus 2, I'm going to be left with minus 2 cubed plus 2 times minus 2 squared minus 2a plus b. So here I've got an equation I'm going to call A. Here I've got an equation I'm going to call B. If I just tidy both of those up, I can say that equation A is going to be A plus B equals 8. And equation B that is going to be minus 2 cubed, that's going to be minus 8. Minus 2 squared, that's going to be 4 plus times 2 is 8, so that's going to go. I'm just going to be left with minus 2a plus b equals minus 1. And I now need to solve these simultaneously. So I'm going to rearrange this. I'm going to say b is equal to 2a minus 1. And then I'm going to substitute b into a. And so equation A is going to look like this. It's going to be a plus, instead of b, I'm going to have 2a minus 1. All of that's going to equal 8. And I'm going to have 3a is equal to 9. And so therefore a is going to equal 3. In which case b is going to be 2 times 3 minus 1, and that's going to give me 5. So the question asks, what are the values of a and b? Well, I can say a is going to equal 3, and b is going to equal 5. And so here I've applied my remainder theorem to this particular problem. Taking that on a bit further, here's an example with both the remainder and the factor theorem. Again, they've given us an expression, a quartic expression this time, with two unknowns, and they've given us two pieces of information. They want you to find p and q. They also tell you, or give you the remainder when the function f of x is divided by x plus 2. So in other words, f of minus 2 is going to be 72. And they also tell you that x plus 1 is a factor of f of x. So in other words, f of minus 1 is going to give me 0. So there are my two pieces of information that I can use. If I go and substitute in over here, x is minus 2, I'm going to get minus 2 to the power 4. Minus 6 times minus 2 cubed plus 7 times minus 2 squared minus 2p plus q. In this situation, I substitute minus 1. I'm going to get minus 1 to the power 4 minus 6 times minus 1 cubed plus 7 times minus 1 squared minus p plus q. Obviously, I need to tidy these things up. That is 16. That is 848. That's 28. So 28 and 48 and 16 make 92. So I can pull that over to the left-hand side. So I can say minus 20 is going to be minus 2p plus q. Here I'm going to have 1. That's going to be minus 1 times minus 6, positive 1. That's going to be positive 1 times 7, so that's going to be 14. So I'm going to get 0 is equal to 14 minus p plus q. So here are my two equations. We'll call this one A, we'll call this one B. And what can I say about this? Well, if I rearrange A, I can say that Q is equal to 2p minus 20. If I go and substitute A into B, well, then I'm going to get 0 is equal to 14 minus p plus 2p minus 20. What am I going to have? I'm going to have a positive p, and that's going to be minus 6 equals 0, and so p is going to equal 6. And if p is equal to 6, then q is going to be 2 times 6 minus 20, and that's going to give me minus 8. Well, the question asks, just find the values of p and q. So there we've done it. So p is equal to 6, and q is equal to minus 8. And there you have two applications of the remainder and the factor theorem. Now you need to go and do a whole lot of work on this. Good luck.